Good morning, students. This is Murthy sir. In the last class, we discussed about the historical background and the salient features of modern periodic table. Today, we will learn about properties of elements and their trends in groups and periods. Before learning the properties of elements, I would like to tell you one thing. When we look at the 4 blocks in the periodic table, in S block, highly reactive elements are there. Highly reactive metallic elements are there. In P block, you will find 3 types of elements. Metals are there, metalloids or semi-metals, and non-metals. So 3 types of elements are seen in P block. Metallic elements, non-metallic, and semi-metals or metalloids. In D block, most important metals like iron, copper, gold, silver, metallic elements are there. And in F block, radioactive elements and synthetic elements are seen. In P block, semi-metals or metalloids, they are shown with a staircase demarcation clearly. Now let us see the properties of elements. The first one is valency. Valency of some elements shown here: chlorine 1, oxygen 2, nitrogen 3, carbon 4. Carbon is tetravalent. Now let us see the definition of valency. The combining capacity of the atoms to form molecules either with same or different elements is defined as valency. Element sodium, it has valency 1 because in its outermost shell 1 electron is there. Valency in a group is same for all elements. Valency in a period from left to right increases from 1 to 4 and then decreases to 0. Now we will move on to the second property, atomic radius. Atomic radius is the measure of the distance from the center of the nucleus to the outermost electron. Friends, let us see the atomic radius of hydrogen molecule. You can see here how it is represented in hydrogen molecule. Students, you might have observed the position of hydrogen in periodic table. It's a gaseous element, it's a non-metal, but it is placed in group 1 along with highly reactive metallic elements. Hydrogen has only 1 electron. This hydrogen is the most abundant element in the universe and it was discovered by Henry Cavendish. Atomic radius is measured in picometers. The symbol is pm. 1 picometer is equal to 10 to the power minus 12 meters. The atomic radius of sodium is 186 picometers. The atomic radius of potassium is 231 picometers. Atomic radius in a group increases from top to bottom. Atomic radius in a period decreases from left to right. Let us see some more examples of atomic radius. Carbon has atomic radius 77, nitrogen 74, oxygen, the atomic radius in picometers is 66. Now let us see ionic radius. Ionic radius is defined as the effective distance from the nucleus of the ion to the point up to which it has an influence in the ionic bond. In sodium chloride molecule, ionic bond is there. This bond is formed by the transfer of electrons between sodium and chlorine atoms. Students, now let us see what is ionization energy. Ionization energy or ionization potential is the energy needed to remove an electron from an atom in the gaseous state. It is represented with the letters IE. Now, let us see what is ionization energy 1 and what is ionization energy 2. Ionization energy 1 is the amount of energy required to remove the most loosely bound electron from an isolated gaseous atom to form a cation. Students, here ionization energy of aluminum atom is shown. The symbol of aluminum is Al. First ionization energy value of aluminum atom is 580 kilojoules per mole. Definition of second ionization energy. It is the amount of energy required to remove a second electron from the gaseous monopositive cation to form dipositive cation. The second ionization energy value of aluminum atom is 1815 kilojoules per mole. Now let us see the periodic trends. Ionization energy in a group decreases from top to bottom. Ionization energy in a period increases from left to right. IE1 is the first ionization energy. IE2 is the second ionization energy. This ionization energy depends on some factors like nuclear charge, screening effect or shielding effect, penetration power of the orbitals, stable electronic configuration, atomic radius. When the number of shells are more between the nucleus and the valence shell, the actor screens and decrease nuclear attraction over the valence electrons. This is called screening effect or shielding effect. More the screening effect, less is the ionization energy. When we compare lithium and cesium atoms, the element cesium with more inner shells has less ionization energy. Students, this is one practical example for screening effect or shielding effect. Students, you can see the representation of shielding effect or screening effect in this picture. Here, outermost electrons are shown, nucleus of an atom is shown, and the attractive and repulsive forces are shown with the arrows. How it happens. Now, we will move on to the next property, electron affinity. Now, let us see the definition of electron affinity. It is the energy liberated when an electron is added to a neutral gaseous atom. Electron affinity is also called electron gain enthalpy. The energy liberated when an electron is added to a uni-negative ion of the element is called second electron affinity of that element. However, practically no element shows liberation of energy when the second electron is added to its uni-negative ion. Now, let us see the values of electron affinity of some elements. It is represented by the units kilojoules per mole. For example, the electron affinity value of chlorine is minus 349 kilojoules per mole. The electron affinity value of oxygen is minus 141 kilojoules per mole. Electron affinity in a group decreases from top to bottom. Electron affinity in a period increases from left to right. Students, now let us see what is electronegativity. The electronegativity of an element is defined as the relative tendency of its atom to attract electrons towards itself when it is bonded to the atom of another element. Electronegativity depends on two factors, effective nuclear charge and atomic radius. Great scientist Linus Pauling assigned the electronegativity values for elements on the basis of bond energies. He assumed that the electronegativity of hydrogen atom is 2.20 and calculated the values of other elements with respect to hydrogen. Electronegativity in a group decreases from top to bottom. Electronegativity in a period increases from left to right. Now let us see the electronegativity values of some elements. Chlorine, it has a value of 3. Lithium, electronegativity value is 1. Carbon 2.5, nitrogen 3, oxygen 3.5. Now we will move on to the next property, electropositivity. Let us see the definition. The tendency of atoms of an element to lose electrons and form positive ions is known as electropositivity. Metals, they have very strong electropositive tendency. The metallic character in a group, it increases from top to bottom. When we see in a period, it decreases from left to right. Non-metallic nature, it decreases in a group from top to bottom, and in a period, it increases from left to right. Electropositivity in a group increases from top to bottom. Electropositivity in a period decreases from left to right. Students, till now we discussed the properties of chemical elements and their trends in groups and periods.